Listen, example 32. Okay, page number 25. A market research group conducted a survey of 1,000 consumers and reported that 720 consumers like product A and 450 consumers like product B. What is the least number that must have liked both products? Okay. So listen, a market research group conducted a survey of 1,000 consumers. So total we have 1,000 consumers. So out of this 1,000 consumers, 720 consumers like product A and 450 consumers like product B. Okay. So we can consider this 1,000 as our universal set or number of elements in the universal set. So n of u equal to 1,000. Now 720 consumers like product A. So let us take the set A. Set A is the set of consumers. Okay. The set of consumers like product A. That is A, set A. So what is n of A? Number of consumers like product A. It is product A. Number of consumers like product A is 720. Now define the set B. B is the set of consumers. Okay, consumers like product B. So what is n of B? N of B means number of consumers like product B. It is 450. So we have three data. One is n of u equal to 1,000. Second, n of A equal to 720. And third one, n of B equal to 450. Okay. So our question is, what is the least number that must have like both products? So we want to find what is the minimum number of consumers who like product A and product B. We want to find the least number, minimum number we want to find. So this is a word problem based on our cardinality theorem. Now define cardinality theorem. What is cardinality theorem? N of A plus n of B minus n of A intersection B is equal to n of A union B. For any two finite sets, n of A union B equal to n of A plus n of B minus n of A intersection B. N of A union B equal to n of A plus n of B minus n of A intersection B. Now put n of A equal to 720, n of B equal to 450 and simplify. 720 plus 450 equal to 1170. We don't know these two values. So we get an expression n of A union B equal to 1170 minus n of A intersection B. So our question is, what is the least number that must have like both the products? Or what is the least number of n of A intersection B? Both the products means product A and product B. So we want to find what is the minimum value of n of A intersection B. It's clear? We want to find minimum value of this n of A intersection B. So n of A intersection B becomes minimum only when n of A union B is maximum. Okay? N of A intersection B is minimum when n of A union B becomes maximum. Let's see some values. Suppose we take n of A union B equal to, suppose 500. Okay, n of A union B is 500. So, n of A intersection B becomes, to obtain 500, what is the answer? 1170 minus 500. That is 670. Okay. N of A intersection B becomes 670. If we take 600, n of A union B 600, then n of A intersection B becomes 570, isn't it? So, value of A union B, n of A union B increasing, automatically the value of n of A intersection B is decreasing. So, the minimum value of n of A union B become only when n of A union B is maximum, and the only chance is n of A union B is 1000, because our maximum value is 1000. So in this case n of A intersection B becomes 170. It becomes the least value. Okay. So we can say that n of A union B is maximum when n of A intersection B is minimum. So, okay. So, the maximum value of n of A union B is 1000, because our total number of consumers is 1000. So, can't exceed this value. So, maximum number of consumers those who selects A or B is 1000. It's clear? So, we can say that the least number of consumers who lack both products A and B is 170. Okay. So this is an example question. Page number 25. Go through the question. Example well. Okay. For example, out of 500 car owners investigated, 400 on car A, 200 on car B, and 50 on both A and B. Is this data correct? Okay, this is another model. So we have out of 500 car owners. So out of 500 car owners means the set of car owners investigated. That is total number of car owners investigated. So we can consider this 500 as our universal set, or number of elements or number of car owners investigated. Okay, 500. So out of this 500, 400 on car A. So define a set A is the set of persons who owned car A, and therefore n of A becomes, what is n of A? N of A becomes, listen, 200. Now 400. Okay. 200 on car B. So define a set B. What is a set B? The set of persons who own car B. So what is n of B? N of B is 200. Now last data, 50 on both A and B. So both A and B means intersection. So number of persons who own both car A and car B is 50. Okay. Now find n of A union B. So by cardinality theorem, n of A union B is n of A plus n of B minus n of A intersection B. Replace all the values here. N of A 400, n of B 200, n of A intersection B 50. 400 plus 200, 600 minus 50, that is 550. So, n of A union B is equal to 550. N of A union B means the number of persons owned car A or car B, that is 550. Is it correct? This is a contradiction. This is wrong, because in our question we investigated out of 500 only. Total we have 500 persons. So this data is, we can say, what? Incorrect data. Okay. So this is the practical problems based on intersection and union with the help of cardinality theorem. So in miscellaneous exercise, some questions are there based on this cardinality theorem. Go through the questions very well, and also complete. I hope all of you complete all the exercise 1.1 onwards up to 1.6. Okay, and in the coming doubt clearance session, please attend and ask your doubt and clarify it.